In our college days, we used to call this as extrapolation or interpolation, right? Math behind this. Now you can imagine how much math is involved behind this, right? So moving forward, okay, now we have to go into hands-on, okay, guys? But before going into hands-on, did you all understand what is training data set and what is test data set? In real life, the test data set, so for example, if you have 100 data points, the training data set will have more data points because that is where your algorithm is getting trained, right? So people will generally take 70-30 ratio, 80-20 ratio, or 90-10 ratio. It depends, okay? 70% of the data going into training data set, 30% of the data going into test data set. Okay, so you always have to split your data set into training and test data set so that your model is trained on training data set, and then you can predict the output for test data set and you can see how well our model is performing. Okay, so training data set, test data set, what all we have learned, different types of errors, how do we minimize that errors using gradient descent and derivatives, how to achieve the optimum value of m and b. So you don't have to worry if you don't understand gradient descent because it's more of maths, but please go back and do the homework. So in the challenges also there is one thing which I mentioned on gradient descent. If you can just go and work on those challenges, you will understand how this gradient descent works. Okay, you're getting my point, right? Until unless you practice, you will not be comfortable. It's simple. You must be thinking in the coding that it's only a one line of code. I will just use those one line of codes. But then, as I always tell, to do the fourth analytics, which is descriptive, diagnostic, predictive, and prescriptive analytics, right? To do prescriptive analytics, you should know what is the math behind it. In Python, there is a simple one line code which you can directly use. But if you want to implement that as a gradient descent method, if you are thinking I want to come up with a best fit line by my own, the Python function, then you have to write these equations in Python and you have to put in for loop because it's a for loop, right? You have to keep on updating b value, m value, and then for which particular b and m you will get the minimum error, right? So that's the whole point. If you want to do it from the scratch, you can do all these equations, you can incorporate in your for loop. But if you want to directly write one line of code, then there is a one line of code which you can do it. But as I always tell, you can write the one line of codes while doing the projects, but for while doing the challenges, it's important that you learn as much as possible. So for that, I recommend if you can do some pen and paper practice also on this, and if you want to write a code, you can also write a code. That would be better for you guys. Okay, this is a machine learning algorithm only. This is a very basic algorithm of machine learning, so which is linear regression. I've also given this as a assignment. Perform gradient descent in Python with any loss function. What do I mean by any loss function? That means any error equation. You can use this equation, RMSE, you can use MSE, you can use mean absolute error. There are different ways of calculating the error, okay? You can use any function which you want. But the most famous one are mean square error and the mean absolute error. For doing the gradient descent method, the famous ones are mean square error and mean absolute error. Okay, making sense? So L1 is called as mean absolute error, L2 is mean square error. Okay, I already told you the difference, but just tell me what are the pros and cons for both the loss functions. There should be some pros and cons, right? That's the reason there are so many ways of calculating error. So you have to work on this, guys. And in this, till now, I have not given any data set on which you have to work. You can come up with your own data set and work on it. Very simple data set, say only 1x, 1y with 5 records. It's up to you because I want you should know how to create data sets also, right? So you can just make your own data sets. For example, torque and price of the vehicle. Very simple data set with 5 records. Changing the torque, you know how if torque increases, you all know, right? If torque increases, whether the price of the vehicle increases or decreases. Okay, you can think on it. I don't want to get into mechanical stuff as of now, but then yes. So take any mechanical example with 5 records and try working on it, because of, I would say, from 7th session, you have to write codes. That doesn't mean that you don't have to write code now. You have to write code now also, but from 7th week, you will have a lot of projects. Okay, so going back to Python now. So I'll just give you the intuition. How does linear regression can be incorporated in Python? Okay, guys. So before that, I'll just tell you few things. In Python, as per date, to become a data scientist, you have to remember 4 or 5 libraries. Because we are beginner now, it's important that we remember 4 or 5 libraries. As we proceed in future, you can go with different libraries. Okay, and I will write down all the libraries names here. So can anyone tell me, you must have heard a lot of buzzwords about data science, right? Can someone tell me what does NumPy do? If you just have some hint, that's it. Because it's important that we should have more interactions. See, what all descriptive analytics which we talk, right? That is where NumPy comes in. For example, let's go to coding window. So if you notice now, guys, this is how we import all the libraries. NumPy, Pandas, different libraries, that's okay. But for example, let me comment this code for time being so that I can go to the basics. Okay, so these are the libraries which I have installed. First, let me explain what is NumPy. Okay, for example, if I have x equal to 1 to 100, I hope you guys are practicing at your home. Okay, there is some syntax error here. Okay. Let me just take simple one because I think I have to write list over there. I have to write range there. Then it will work. But anyways, let me take a simple example. Okay. I know there is no comma between 3 and 4. That's okay. Okay, now we have printed x, right? Now if I want to find the mean of x, it says mean is not defined. Okay, it will come by practice that we should know which functions are placed in which library. Okay, I also don't know everything. It's just that by practice you will come to know what all functions are placed in what all libraries. So NumPy is a library where mean is stored in. So we have imported NumPy as np, right? So if you write np.mean of x, then I believe it should work. I have to print it. So the mean is 10.5. So did you understand? So similarly, mean, median, everything will be in NumPy. And Pandas. So what is Pandas? See, in real life, we work with a data set, right? Data set in the sense you will have lot of records, you will have lot of rows, you will have lot of columns. In data science language, we call it as lot of records as lot of rows and lot of features as lot of columns. So let's go with data science language, lot of records or observations and lot of features. So features are x1, x2 and so on, and the output is say y is one more feature. So this data set is kind of matrix, right? But the problem is a matrix will always have the numerical data or similar kind of data for all the features. But when we work on the data real life project, there might be some features which will have numerical data. There might be some features which will have categorical data, which you have to convert into numerical. That's of course. But then there might be some features which will have discrete data, right? So for those kind of data, there is something called as data frame. Or if you want to import an Excel file, for example, then you have to import it as a data frame in Python. So for example, I have one Excel file. I am importing it as the Excel file is say XYZ. So you will get the recording. You can write the same line of codes, but I would always recommend that you guys keep practicing. Okay, just try to play around with the code. So this is where Pandas come in. Pandas is the one which helps you in lot of things, but the main advantage is you can create a data frame directly by importing a file. And by importing this file using this function read underscore CSV, I'm creating a new data frame. Now if I print this, For example, you will see that there is a new data frame which is coming in. There is a new data frame, and for one of the values there is no value. Okay, but you don't have to worry as of now. For this case, there is a special way for handling the missing values, but don't worry about it now. So what it says, area, bedroom, and age of the apartment. So based on that, we are predicting the price. So how many X we have? X1, X2, and X3, and then we are predicting the price. Okay. So it's very simple. I'm just importing the file. Now I'm trying to, by only one syntax, by using only one function which is describe. See, by using only one function which is describe, I'm able to get the count, the number of observations, which is 5, the mean for each feature, area, bedroom, and everything, the standard deviation, the minimum, 25 percentile, 50 percentile, and 75 percentile max values. So these values we are able to get it by using directly one function. So this is what you need to do, guys, exploratory data analysis. This is only one thing. You have to do a lot of things. You have to plot the graph, you have to plot scatter plots, you have to plot bar chart, go and explore what is the function for bar chart, what is the function for histogram, try to understand the data, understand whether the data is normally distributed or not, what happens if the data is not normally distributed. So please explore it. Okay, so when you work, then only you can explore on this. So this is function for median. I don't need this anyways. Okay, this is for mean. That's okay. So I'm just using this command, 2 lines which I'm highlighting here, 19 and 20. I'm just trying to replace this missing values with a median value. Now why I'm replacing with the median value? I can also replace with mean. See, there is a particular feature, bedroom. In this, there is a missing value, right? So I have to fill this because you cannot work with a missing value data set. So whenever you are working with a missing values data set, you have to implement imputation. This is again a separate technique which you will learn later on, but you can remember this. Imputation is a technique to handle missing values. And imputation, there are different techniques. One of them is just find the median of this feature 3, 4, 3, 5 and replace this missing value with median of that. The other way is replace the value with mean. There are different ways, guys. There are different ways. Okay, but anyways, now the important thing is we know what is NumPy, what is Pandas, what is Matplotlib. As the name suggests, all the graph libraries, most of the graph libraries or most of the graph functions will be placed in this library. So far so good. We know what is NumPy, what is Pandas, what is Matplotlib. Then what is Skill-Learn? Skill-Learn is the heart of machine learning. All that one line of code which I was talking about, all those one line of functions are already inbuilt in this Skill-Learn. Okay, and again, you know what is the backend of this one line code, right? Gradient descent, which we have learned, but that is already in place for that one line of function. So what I am doing here is from Skill-Learn, I am importing linear model. In that linear model, I have a linear regression, which is inbuilt. Okay, so I'm assigning linear regression to one variable called as regression. Making sense? I'm assigning linear regression to one variable called rig, and then I am fitting the curve between all the inputs and output. See, inputs are separated and output is separated by this. Okay, so this is the syntax. The variable dot fit all x comma y. Okay, did you understand how what did I do using imputation? So far till imputation it is okay, right? I'm just replacing the missing values, right, Naga? There are different ways of doing imputation, but the simplest ones are mean imputation and median imputation. Now what I am doing here is, see, there is a library called as Skill-Learn. In that there is one function, or I would say, let's say there is a one function by name linear underscores model. In that linear underscores model, there are different functions inbuilt, in which one of the functions is linear regression. And for our challenges, for our course, for this session, we need linear regression, right? So this is how we have to assign the linear regression in one of the variables. This is a basic step what we have to perform. Okay, so far so good. So I'm assigning the linear regression function into one variable called as reg. Now I have to fit the curve between x and y, between inputs and output. In our case, we have 3 inputs and 1 output, right? So this is multi-linear regression, right? This is not simple linear regression, because in simple linear regression, you will have only 1 input and 1 output. Here we have 3 inputs, multi-linear regression. So these are inputs, right? Please note down here also. At the bottom, if you see this table, this is your data frame or data set. In Python language, data set is called as data frame. So these are your inputs and this is your output, and this is the syntax which you have to write for fitting your inputs and outputs. So far so good. Please write yes or no. Once I fit the model, my linear regression is built and it is stored in reg, because we are already denoting linear regression with reg, and this linear regression is fitted as per our data set. So now we have built the linear regression equation. Now to look at that equation, see, we know what is y, what is x. Y is price, x1 is area, x2 is bedroom, x3 is age. What we need to find is coefficient, right? So if you print reg.coef underscores, what we are seeing here, these are the coefficients. If you want to write the equation, you can write it, but it's not required, because now reg has everything. This reg variable, it has our best fit linear regression line. So for each variable, you have each coefficient, and if you want to print the intercept, you know what is intercept, right? Right, guys? Mx plus b. M was the coefficient for x, b was the intercept. But here we have 3x, x1, x2 and x3. So now you can always write the equation with this. You know y is equal to 137.25 into x1, which is area, plus this coefficient into x2 plus this coefficient into x3 plus the intercept. Now you have the equation. Now whenever you get new x1, x2, x3, you can calculate the y using equation, right? But you don't have to do that. You can directly do that in the Python. Now, for example, if you have new values of area, bedroom and age, then you have to write these 3 new values and you have to write. So it's very simple, right? That is how builder also works. So if you are working as a civil engineer, for example, and you are an advisor for one of the builders, then it's important that you should be able to predict the price for different flats, right? Then, for example, for new, so this, our model is built on the training data set. Now this is our new test data set on which we are trying to predict. And the syntax is reg.predict, simple. Now let's predict that. So for this new values, the price is 5,88,000. Let's think in this way, guys. When the area was 2600, the price was 5,50,000. When the area was 4,000, the price was 7 lakhs. But again, if you notice this 3,000 and 3,200, for example, this area with 3,200 and area with 3,600, what we think? Bigger area, higher price. No, not really. It depends on the age of the flat, right? This is the older flat, so the price would be lesser, right? So we have to analyze, and then for the new test data what we have given, whether this price makes sense or not. Simple. Making sense? Now you know we have got all the R square. Sorry, you have built the model, you have done the prediction, but how well your model is predicting, that is dependent on your R square value, right? For that, the syntax is reg.score. Reg.score between your input and output. Okay. So you have to just write reg.score. So if you notice, R square value is 0.94, which is very, very good. In real life, it is very difficult anyways, but then it is important to know what is this R square. So the model what we have built is predicting very well for the given data set. So we can use this linear regression model for predicting the price for future data set or for any test data set which is coming in. So there might be today someone might have asked you, some new client comes to you and tells you that, see, I want the area of the flat, say 4,000, but I need only 2 bedrooms. Okay. And it should be only just find me a flat with 4,000 square feet and it should be having only two bedrooms. That means very spacious bedrooms. And then the flat should not be that old. It should be only 2 or 3 years old. Then you should tell to your client that you can predict the price somewhere near to this. For example, say 4,000 area and 2 bedrooms and only 2 years old. So tell me, now if you notice the price is 8 lakhs, and which makes sense, right? If you notice from this, for 4,000 it was 7,60,000. Now we have 4,000 square feet area, but the flat is new, right? So the price should be higher. So it's logical. So this is how you have to always interpret the results, guys. Don't blindly follow the results. Interpret the results, whether the results what you are getting, is it really making sense or not? So this is one of the simple example which I have taken for civil engineers, but then again you can take different examples. For example, you will be doing this assignment anyways in your projects. Once you complete 6 weeks of course, there is one assignment, there is one project where you have to predict the mileage based on the horsepower of the vehicle, based on the volume of the vehicle or volume. So based on the different parameters, you have to predict the mileage. So that is a multi-linear regression problem. So you have to predict the mileage. Okay, so far so good. But remember, this data set was very small. Ideally, you will have a very big data set. So as I told, you have to split the data set into training data set and test data set. You have to build the model on training data set and then you have to predict for test data set. But this was a very simple model. That's the reason I have taken a very simple data set. So I have taken all the data sets for building up the model. Okay. But in real life, you will have a lot of data sets. So for that, you have to split the data set 70-30, 80-20 or 80-20 or 90-10. It's up to you. Where you are getting better accuracy and where your results are interpreted in better way, or where your results are making more sense. Okay. So did you all understand this line of codes? See, if it's very simple, right? The one line of code which is important is this, right? So you have completed, it's just that in within 10 lines, you have completed your machine learning model. But if you think in this way, it will not be helpful. You should understand what's happening at the back end, right? Similarly, you will have a lot of different algorithms. So this linear regression is used for predicting the price, sales, continuous variable. In next session, we will see how to predict the class. Okay. So before logging out, I just wanted to ask you one puzzle and then you can start asking your questions. Okay. So the puzzle for today's session is how many rectangles are there in a chessboard? I assume that you all solve for a puzzle of how many squares are there in a chessboard, right? Please solve a puzzle where you have to calculate how many rectangles are there in a chessboard. Please solve it. Now, please put in your questions in the chat box.
So we have one question regarding equations for business moments in class. Is there any material for where we can get details of the same?
You don't have to find a specific material. You just need to write in Google or just write what are the 4 business movements in Google. You will directly get it. So you don't need to specifically refer any material for that.
Equation, yes, a follow-up question. Equation appears different from the same, especially quarters.
Okay, so there could be a chance different guys. So see, this is important. Okay, see, for different websites, I believe you must be thinking the equations might be slightly different, but that's it depends. Okay, see, for the different analysis, they choose different kind of formulas, but the formulas which I have written are the standard ones. So you will see a lot of things in statistics, more about how you analyze. For example, you're doing a failure analysis, and in your analysis, the probability for a machine to fail is say 0.7%. Then what you will infer from this? That machine will fail because you will assume that 0.5 is your threshold limit for your probability, right? If the probability of failing is less than 0.5, then you will think it is not failing. If it is greater than 0.5, then you will think it is failing, right? But in reality, it's not the case. The threshold value of probability is again calculated based on different analysis. Okay, so similarly, it depends on the analysis. But the important thing is, what is the importance of kurtosis? Formula is not important, as I always tell. What is the importance of kurtosis? Did you understand what I'm trying to tell? Yes, you're right. It's a measure, but I want you to think in terms of, you have to come up with some examples where kurtosis can be really important. I have not given any example on kurtosis, if you remember. I've given you examples on skewness, variance, central tendency, mean, median, but I have not given any example on kurtosis. So when you try to look for the examples on kurtosis on internet or explore yourself, please explore it, okay? And then only by this you will learn a lot of things. Thank you. Any more questions? And also, you guys are solving puzzles or not, guys? Just listening to the classes will not help, guys. You have to practice. Okay, then if there are no questions, then I'll take a leave. Let's catch up tomorrow again. We will be looking for classification problem, okay, which is an extended version of linear regression, which is called as logistic regression. So let's catch up tomorrow, guys. Thank you.